Okay, all right, so we're on number 19, question number 19 on 5-2. Okay, so they give us what? Is that what, a cube root? Cube root of 6, cube root of 72. Over the cube root of 2. The cube root of 2. Okay, so while you're jotting that down, I'm going to put these, I did this differently, 6th hour, a little bit different than 6th hour than I did 2nd hour. I think it worked a little better. I'm going to put these notes up here. I'm going to reference them. First example is like x2 times x3. These may not be exactly the same examples I gave you, but they're very similar. If I gave you x2 to the 3rd, x to the 6th, if I gave you number 3, if I gave you 3 to the 1/4 times 5 to the 1/4 is 15 to the 1/4. And if I gave you, you might want to use a different sharpener. That thing works terrible. If you want to go find Bane's room or something, or there's a.
Garrett, I have a pencil.
There's one in there. Okay. What was the other one? I know I gave you x to the 8th over x to the 3rd equals x to the 5th. Is that all that we went over? Did you check your notes? Can I look at them real quick? I missed it. That's everything you cover. That one we did, that one we got, that one we got. That we got. Okay, that'll work. Okay, so these are just examples 1, 2, 3, and 4. Okay, so when we're looking at this one right here, okay, any idea which of them we're going to probably use? We're going to use a couple of these examples in order to do this one. I mean, like, do you think we're going to use the example from number 1 or 2 or 3? Any guesses? What's that? Definitely 4 at some point. Definitely 4. We can divide them. Okay? And it's kind of hiding here, but we're also going to do this one right here. We're going to use this one right here. Okay? And what we're getting at is this. We can times the basis if the exponents are the same. Now, you don't really see exponents here, but you could rewrite it with exponents. I'm going to do that. That's the same as 6 to what power? The 3 over 1 or 1 over 3? What do you guys think? Would it be 3 over 1 or 1 over 3? 1 over 3. 3 is the first thing, so it's going to be the last thing. 6 to the 1/3 times, again, this is 72 to the 1/3 over 2 to the 1/3. Okay, so if we write it like that, it looks a little more like number 3. When we times, if the exponents are the same, you can times the bases, and the exponents stay the same. So we do that. We're going to take 6 times 72. You can always use a calculator. That's 432, I think. 432 to the 1/3 power. I want to check that. 420, yep, it's 432. Okay, that looks terrible. Okay. Now, any idea what we're going to do now? Okay. Yes, ma'am.
I just have a question.
Uh-huh.
So when we're when you do the adding, do they have to be the same base?
Yes, they do.
Okay, so that's why we're not adding.
Right, yeah. This one, we cannot add 1/3 and 1/3 because the bases are not the same, okay? But if the exponents are the same, this is what's really tough. This is what it's simple adding and multiplying. We all know how to add and multiply, but it's just remembering when you do what in each one of them, okay? When we're timesing, if the bases are the same, we add those. But if we're timesing and the exponents are the same, we times those. That's a tough one, okay? I very likely, I'll say 80-85% certain that I'll give you examples like this on your next test, which isn't for a while. It's another 2-3 weeks at least, okay? At least 2 weeks, probably more like 3 weeks or so, okay? So it's easy stuff, but it's easy to mix them all up. Yes, ma'am?
I'm not sure if this is like what she was asking, but since it was the same root, could you multiply the 6 and 72?
Exactly. You didn't have to rewrite it. You didn't have to. The reason why I rewrote it was this. Answer truthfully here, okay? Do you see radicals right here? Do you see them?
No.
But they are there. I mean, they are there. 3 to the 1/4 power. I could rewrite it as the 4th root of 3 to the 1st. They're there. They're just hiding, okay? The reason why I rewrote it is so it looks a little more like that. I mean, it's not, you might be saying, I can use this one. There's no radicals in it. Well, they are. They're just hiding, okay? So you ask, can we times them? Yes, we can. And that's exactly what we did. 6 times 72, okay? All right, any idea what we do next? I mean, if you listen to what we just, huh? Who's talking? Why are we dividing? We can divide them?
Yeah,
Why?
the same.
What's, same what?
Power.
Same power. It's the same thing we just did. If we're timesing and the powers are the same, we can times them. If we're dividing and the powers are the same, we can divide them. We can do that. So 2 goes into 432, 216 times. Okay? And the exponent stays the same. Okay? Now, if you're not sure what 216 to the 1/3 power is, rewrite it. The cube root